Okay, hello everyone. Welcome to MCLA. Thank you again for joining us tonight for the second of our two presentations about the critical choices that currently face us with regards to how we manage our forests. So quickly before I introduce tonight's speaker, I would like to also invite you to join us tomorrow and every Thursday evening continuing through April 16th to hear from experts on environmental pollution. Tomorrow's talk, Thursday, David Bond from Bennington College will give a lecture titled PFOA in New York and Vermont. So last month when we were gathered here, we heard from Dr. William Mumma, Emeritus Professor of International Environmental Policy and Founding Director of the Center for International Environment and Resource Policy at the Fletcher School. We are fortunate to again have Dr. Mumma joining the Q&A following tonight's presentation. A bit about his background. Again, he currently serves as the co-director of the Global Development and Environment Institute at Tufts, which he co-founded. He received his BA degree in chemistry from Williams College and PhD in physical chemistry from MIT. He had a 26-year career in chemistry and environmental studies at Williams College, where he directed the Center for Environmental Studies. He served as AAAS Science Fellow in the U.S. Senate, where he worked on legislation that successfully addressed ozone depletion and on legislation responding to the 1973 energy crisis. He began working on climate change in 1988 as the first director of the climate program at World Resource Institute in Washington. He's been a lead author of 5 Intergovernmental Panel on Climate Change reports, and as you remember, the IPCC shared the Nobel Peace Prize for its climate work in 2007. Tonight, I'm honored to introduce Frank Lowenstein, who currently serves as Chief Conservation Officer of the New England Forestry Foundation. He holds an MS in Botany from the University of Vermont's Field Naturalist Program and a BA in Geology from Harvard University. Prior to his work with the New England Forestry Foundation, he served as Global Director of Forest Health and as Global Climate Adaptation Strategy Leader for the Nature Conservancy. In that role, he participated in the global climate negotiations under the United Nations Framework Convention on Climate Change, attending the negotiation sessions in Mexico and South Africa in 2010 and 2011. His practical conservation experiences include leading community-based conservation for the Nature Conservancy in the Berkshires. He's taught courses on conservation and climate change at Brandeis University and for the Masters of Sustainability program at Harvard Extension School. He served as a Switzer Fellow, a Senior Fellow in the U.S. Department of State's Energy and Climate Partnerships of the Americas, and on board an executive committee of the UN-affiliated Global Invasive Species Program. And we also invite you to listen in to NPR's Science Friday on WAMC for more on this topic when you'll be hearing from Frank and others about forests and climate. Thanks so much for doing this tonight.
Tonight we're going to talk again about the climate crisis, the climate emergency that is facing us. We are in dire straits, as Dr. Mumma showed us a month ago. Just so I know, how many of you were here for Dr. Mumma's presentation? Most, but not all. Okay. So that helps. I will cover some ground again. So we are facing a really, really tough situation, and Dr. Mumma and I agree on about 95% of what we should do about it. So we'll spend most of our time talking about the areas of agreement, because my experience is when you focus on areas that you can agree on, you can make progress. And I'll highlight the areas where we disagree just so everybody knows it, and you guys can ask questions about it if you want to. So, one of the key concepts I want to focus on tonight is the idea of frame, and that what the right solution is and what the problem even is depends on the frame that you're looking at. So, everybody knows what that is, right? What is it? It's a tree. Someone says it's a tree. Is it anything else? It's a sugar maple. No, it isn't actually. So, yes, it's a northern red oak. I was expecting people to say bark, and then when we pull back to the larger frame, it's tree. But, whatever. So, let's dive in, but keep in mind this idea of frame. What are the boundaries of the system that you're thinking about? And what are the boundaries that you're using to define your solutions? So before we dive in, I want to just ask a few things. First of all, How concerned are people here in the room about climate change? What? You're concerned, I take it?
Very.
Okay, so you're very concerned. Who else is very concerned? Most people in the room. There's a little bit of self-selection. I'm very concerned too, and my concern originated actually when I was an undergraduate at Harvard University, and I was the president of the Harvard Outing Club, and I fell in love with cross-country skiing. And I was out cross-country skiing today with my buddy Neil Chamberlain. Neil, raise your hand. And I love cross-country skiing. As far as I'm concerned, the only reason to live in New England is to have snow. And so if you don't have snow, that's a problem. That's why I first got interested in climate change in 1983, and I wrote my undergraduate thesis on coastal erosion and climate change. And eventually I came to realize that it was more than just about my pleasure, that there might be some other issues, and we'll talk about those other issues in just a minute. So, everybody's very concerned about climate change. How do you guys feel about forests? We have a thumbs up for forests. 2 thumbs up for forests. Anybody not really like forests isn't here because they have an affection for trees? Okay. A few years back, when I was heading up the Forest Health Program, Elena, it wasn't the global Forest Health Program, it was only North America. For the Nature Conservancy, we did some polling work. And our pollster came back to us and he said, Frank, I've never seen numbers like this. 96% of people say that trees give them a feeling of peace and tranquility. 92% of people report that woods and trees are important to their sense of community. People love trees. Americans love trees. And that cuts across all the other divisions among us. And he was saying, it doesn't matter what I poll on anymore. I never see more than 50% of everyone agreeing on anything. This is crazy. So, you guys are not alone in your affection for trees. And I, of course, also love trees, or else I wouldn't do what I do now and what I've been doing for my entire career. And how do people feel about harvesting trees? 1 thumbs up, 2 thumbs up, sort of a thumbs up. We have some so-so, we have someone who's sad about it. Yeah, so more mixed feelings. That's important to recognize, and there is absolutely nothing wrong with those mixed feelings. And, for someone who works for a conservation organization that has been working for 75 years to conserve New England's forests and to promote better forest management, I will tell you that a lot of the harvesting of trees that happens, particularly in northern New England, is not especially well done. And I'm going to show you an image of that, and I think it affects this question of frame and what we should do here in Massachusetts. Okay. So, let's start with climate change. What are the basics of it? Well, first of all, it's been recognized that carbon dioxide in the atmosphere warms the planet for a long time. The famous Swedish physicist who also won the Nobel Prize, Svante Arrhenius, published on the role of carbon dioxide in warming the planet in 1896. In 1912, you had this article that appeared in a New Zealand newspaper, which I love, that talks about the fact that we're burning about 2 billion tons of coal a year, and that adds 7 billion tons of carbon dioxide, which over time could result in a considerable effect. So this has been recognized for a long time. It's also not a bad thing. Without carbon dioxide in the atmosphere, the Earth's equilibrium temperature, averaged across the whole planet, instead of being about the 59 degrees Fahrenheit that we enjoy today, would be about 0 degrees Fahrenheit. You would have a narrow zone of habitability, maybe, along the equator, and you would have the area where we're standing now would probably be under ice sheets, where I'm standing now. You guys are not standing, would be under ice sheets and not habitable. So carbon dioxide is important. The problem is that right now we have too much of it, and the effect is very much like piling a blanket on when you're already warm enough at night. What happens? You get sweaty, you'll wake up, you're uncomfortable, maybe you even have to get up and change your clothes, like change your whole system up. So we're going to have to do that. Okay, so why is it urgent? Why is it an emergency? This is from a graph from the IPCC's report in October of 2018 that was commissioned out of the Paris Climate Accords in 2016. And the question that was put to the IPCC was, what's the difference between 1.5 and 2 degrees Celsius? Does it really matter how warm the planet gets? And there's a few things, of course, being scientists, they couldn't just look at one issue. They did a very comprehensive job, and there's a lot of information in that report. And most of the reporting on it that you saw in the popular press really didn't dig into some of the really scary stuff. This, to me, is the second scariest graph in the report. I'm going to show you the scariest one in a minute. And what's scary about this is this little red bar right here. That red bar is showing the dates when we might exceed 1.5 degrees Celsius, which is the threshold that has been identified today as the threshold of dangerous climate change, which is somewhat of an arbitrary threshold across a continuum. Really, I think we could argue that climate change is already dangerous. But 1.5 degrees Celsius is the threshold that the world community has said, let's try to avoid going over that. Well, when are we going to hit that? Somewhere between 2030 and 2052. Okay, that's pretty soon. My middle schooler will be in college in 2030. Right? I'm already saving for his college. I'm already planning for his college. What are we doing to plan for going over the level of dangerous climate change in just 10 years? The answer, unfortunately, is very little and not enough. This is the scariest graph. This is how fast we have to reduce emissions in order to have a good chance of avoiding going over 1.5 degrees Celsius or even 2 degrees Celsius. And the answer is we have to get to net zero by about 2040, and we have to reduce emissions by about half by 2030. The steepness of this curve is steeper than has ever been achieved on the planet. The fastest reduction in carbon dioxide emissions that ever occurred was in the Soviet Union after the economic collapse that accompanied the collapse of communism, and they managed to sustain 5% carbon dioxide reductions for a few years, accompanied by the loss of 1/3 of their GDP. Not the model we want. So, what are we going to do? And just to make it worse, the truth is, all of us, by global standards, I don't know anything about any of your economic status, but by global standards, everyone in the room is rich. And there are plenty of people living in abject poverty in the world who are counting on access to energy to pull themselves out of that poverty. And any sort of just system on a global scale, which is what you can't manage carbon dioxide except on a global scale, is going to require us in wealthy countries, Europe, Japan, Taiwan, Australia, to reduce our emissions even faster so as to create room for that just aspirational growth on the part of developing countries and people in poverty. Everyone with me so far? Great. Okay. So we're starting to see some pretty severe climate effects already. All of you, I'm sure, followed at least in part the fires in Australia, the fires in California. Maybe you didn't know about the fires in Bolivia. They didn't get as much publicity, but they were very, very severe. The fires in the Amazon last summer. We are seeing massive increases in fire and in tree mortality associated with fire and drought. And that's actually another problem that we'll talk about. At the same time, we're seeing increases in flooding. And I have a whole series of slides where I show this series of unprecedented floods that occurred every single year in different parts of the globe. And that word, unprecedented, is, it's what we're going to face every year from now on. We are out of historic conditions already. How far out of historic conditions? I'm going to skip that for now and come back. No, I'm not, because it's too far in. Okay. We are very far out of historic conditions. The entire history of civilization of any sort, the 10,000 years that people have ceased being hunter-gatherer animals, not that different than chimpanzees, and built civilization, temperatures have not varied more than 0.5 degree Celsius up and down until now. We are in completely unknown terrain. And, unfortunately, every single piece of infrastructure on the planet is based on historical conditions. Culverts are sized based on historical floods. Air conditioners are sized based on historical heat waves. Bridges, like culverts, are sized based on historical floods, etc. None of it works. None of it is immune to not working. Let's put it that way. I'm going to blank on whether it was 2012 or 2013, the same year as Hurricane Sandy, whichever year that was. 12? Yeah. That year, the Millstone nuclear power plants in Connecticut had to shut down. And Connecticut overnight lost 40% of its electric supply. Why did they have to shut down? They had to shut down because Long Island Sound got too warm. So if you think about nuclear engineers and their specificity with design and their care with how they manage risk, it's not likely when Millstone was built 40 years ago that there would have been any probability whatsoever of Long Island Sound getting warm enough that it would not be usable for cooling. So we are in unknown terrain. Okay. What are we going to do? We're going to have to adapt to climate change, and we need to mitigate climate change, and we need negative emissions. What do those three terms mean? Well, adaptation is action to reduce climate risk without changing how much climate change is happening. Mitigation is action to reduce climate risk by changing the amount of climate change that's happening. So here's an example. This is from 2005 and shows the track of two Category 5 hurricanes, Hurricane Katrina and Hurricane Emily. Both of them hit large cities that were partially below sea level, that had only two roads out of them, one of which was a coastal road that wouldn't be usable in the face of a hurricane. And both of them were subjected to roughly similar winds, rains, tides, etc. And the difference is that in Katrina, there were 1,800 and some odd fatalities, whereas in Hurricane Emily in Mexico, I believe there were, let me check, 15 fatalities. What was the difference? The difference was Katrina, people responded to the hurricane coming by getting in their cars and attempting to drive out that one road, right? And people ended up in, as you would guess, as you would expect, as you would predict, people ended up in traffic jams that were not moving. People abandoned their cars, which made it worse because then there were abandoned cars in the way. Interestingly, the authorities didn't make it only one way out of the city, which they could have done. They didn't do that, so that you could have used both sides of the highway. So people were trying to leave primarily in cars. Mexico banned cars from the highway, and they commanded every bus in the southern third of Mexico to converge on Cancun. And they bussed the entire population out of the city. So that's adaptation, right? The climate impacts were roughly similar. The result in terms of human suffering was hugely different. And it wasn't a physical adaptation. They didn't build a wall. It was just how they managed the system that they had. We probably could have done something exactly the same, but we didn't. Here's another example of the challenge of adaptation. This is one that's harder to deal with in a way. In the Four Corners area of Mexico, there's a bunch of pinyon pine juniper forests. And these forests have been experiencing increased mortality. All the trees that are red in this photo, they're dead. They're dead from bark beetles that are experiencing outbreak populations because winter temperatures are not getting low enough to kill the larvae in the bark of the trees. And so you're seeing just massive mortality that then leads to spectacular fires. This is the Las Conchas fire. The Las Conchas fire, prior to this fire, the largest fire ever in Mexico had been the Los Alamos fire, which had burned 41,000 acres in 2 weeks. This fire burned 41,000 acres in 14 hours instead of 14 days. It produced fire tornadoes. It produced a 45,000-foot high column of smoke. And when it was done, the landscape looked like this. What's missing from this landscape other than the trees? Anything. Okay, but particularly, what do you need to recover from this event that is no longer there? Soil. Yeah. The soil is completely burned off down to the mineral subsoil. This is largely a near sterile landscape. And there have been a lot of concern that this might, absent intervention, this might take hundreds of years to revegetate it all. Then it rained. And you had this event. That's a reservoir, which also produced a lot of erosion. And the city of Albuquerque had to close its water intakes into the Rio Grande for 2 weeks because there was too much sediment and charcoal in the river. They couldn't handle it. They couldn't filter it. This is what I was talking about, that we're in a new world, new landscape. These sorts of impacts are only going to get worse, and we're going to have to learn to deal with them. One thing that Craig Allen, whose photos these mostly are, he's a wonderful scientist with the U.S. Geologic Survey. He's published this really interesting article on drought and heat-induced mortality events in trees that's basically documenting this isn't just the southwestern U.S., it's not just Australia, it's a global phenomenon. It's happening everywhere. So, we happen to live in what's often called by foresters the asbestos forest. It doesn't burn very much. What responsibilities and opportunities does that present us? Or do we have to instead think about, is it going to start burning, and what do we need to do to prepare for that? Because our landscape is much less well prepared than Australia and California are. Okay. Let's turn from adaptation to mitigation. First thing to know is the Paris Climate Accord is completely inadequate. It's a great thing. It's the best we could do, primarily because of the complete rejection of science by one political party in one country on the entire planet. So the result of that was that no binding agreement could be placed. Instead, the entire Paris Accord is based on voluntary commitments by each country. And as you might expect, given that situation and given the United States' role as the country that was blocking binding action, a lot of other countries looked to our commitment to say what they were going to do. And so we sort of set the bar, set the threshold. Well, the bar, as it turns out, if you look at all the countries put together, is that we would hit about 3.2 degrees Celsius if all the countries of the world actually did what they said they were going to do. And so far, most of them are not. That's a problem. Why is 3.2 degrees Celsius a problem? Well, the IPCC study that I mentioned in 2018 estimated the difference between 1.5 and 2 degrees Celsius in terms of economic impact. And it was a $19 trillion extra economic impact, economic damages that would occur as a result of climate change. So when You hear Bernie Sanders say we need to spend $12 trillion to fight climate change. Well, how much are we going to save on the other end? And part of the answer is that 19 trillion is really just the tip of the iceberg. Because the Tyndall Center, which did the analysis for that 19 trillion, they also estimated what the damages would be at 3.66 degrees Celsius, which is basically what the commitments under the Paris Accord to date are aiming towards. And it wasn't 19 trillion. It was well over 400 trillion. It essentially is equal to the value of all the infrastructure on the planet today. Every house, every building, every bridge, every railroad. We'd have to rebuild them all. Do we think we can do that economically? So when you hear people say we need to spend trillions of dollars to fight climate change, they're right. We do. And we need to do that to avert having to spend many trillions more, tens or hundreds of trillions more, to repair the effects and the damage. This got no publicity whatsoever. Nobody really paid, even among the scientists I know, very few are aware that Tyndall Center actually estimated the higher temperature impacts. It's worth noting they also estimated the higher temperature impacts for coral reefs and biodiversity and land submerged and refugees around the world, and those are all exponentially greater too. Lovely. So, it's worth also noting that it's not just that there's all these developing countries with people living still in poverty that need to have a just chance. We have real economic issues in our own backyard. The Metro Mayors Coalition in Boston called for building 185,000 new housing units between 2015 and 2030. Where are those housing units built? What are they built out of? What are they built on top of? Right now, the pattern is you either build concrete and steel multifamily dwellings, and to make either concrete or steel, you have to heat it to 2,500 degrees Fahrenheit, or you build single-family dwellings, typically on the urban fringe, and you cut down the forest in order to build them, releasing the carbon that is stored in the forest. Neither of those is a viable solution. If we do this 185,000 new housing units in Boston and similar ratios in Hartford and Worcester and Springfield and Pittsfield, and we do it the same way we've been doing it, we're going to be in trouble. So just like if you have too many blankets on your bed, maybe you need to take a blanket off. That would be good. But maybe you can't do that, so maybe you need to change to a lighter pair of pajamas. We need to change how we build stuff. Okay, so let's turn to, I've got more than, I'm almost done with the gloom and doom part of this talk. I actually am going to end on a positive, hopeful note. So this is my rabbit, when I get to that, it'll be my rabbit out of the hat moment. So this is a study that came out in 2018 that hasn't perhaps gotten as much attention as it should yet, that looked at these tipping points that scientists have identified. Scientists have identified these ways that the climate system could change suddenly and somewhat irreversibly. And they've estimated how much warming would have to occur before these things start to happen. And for most of them, it's 3 to 5 or maybe even more than 5 degrees Celsius, which we can probably avoid going that hot if we keep trying. But what Stefan et al. Did was they looked at whether some of the lower threshold elements might be able to trigger the higher threshold elements at a lower temperature. In other words, accelerate the probability of these higher temperature tipping points coming into play as well. These are really devastating things. They are going to really create massive, massive problems for us. They include things like the Amazon rainforest shifting to being the Amazon savanna, with a massive flux of carbon into the atmosphere and a massive reduction in the amount of moisture released from the Amazon that will impact weather and climate patterns across the entire Western Hemisphere. It'll hit us too, not just South America. It includes the melting of the east and west Antarctic ice sheets, which could raise sea level by tens of feet. We're just not, maybe we can build a wall to protect New York City. There's some talk of that already. Maybe that value of New York City will be considered high enough that people will do that. What about New Bedford? What about Mystic, Connecticut? What about, pick your place, Portland, Maine? Probably we can't afford to build seawalls to protect all of our cities, all of our coastal communities, all of the places that people live. So we're going to have to instead prepare for where are those people going to move. Get ready, Berkshires. You guys happen to have chosen to live in one of the parts of the world that has the least damaging climate impacts projected from climate change. But what you're going to get instead is a massive influx of refugees, not necessarily from Mexico or Guatemala, but from Boston. And that could be even worse. I don't know. Okay. I'm going to skip that one. So, solutions. We know what to do. We know how to remove our dependence on fossil fuels, which lies at the root of the climate crisis. McKinsey & Company has been putting out this graph, which policy wonks love. One of my favorite policy wonks told me, scientists want a 30-page paper, policy wonks want a great graphic and 5 bullet points. So this is the great graphic. McKinsey has been using this for years now, updating it. You can download it off their website. And the way this graph works is it shows cost. I happened to download the European version, my apologies. It shows cost in euros on the vertical axis. And everything below 0, it actually saves money if we do that. It saves society money. It creates more resources to do something else that we would like to do. Whether that money accrues to the general public or to the private owner that owns the particular land or the particular intervention isn't specified. The width of the bar is how much of a difference it makes, how much carbon it can remove from our annual emissions of about 38 gigatons per year. And look at that. On their chart, we've got enough solutions available today that we could remove that whole 38 gigatons and not emit any more carbon dioxide. This is not a technological problem. It is not a scientific problem. It is not even an engineering problem. It is a political will problem. Now, I want to highlight that there's a lot of people who are way into the idea that our solution is just we're going to capture the carbon that's coming out of our existing power plants, or we're going to build bioenergy power plants and capture the carbon coming out of those. That is the most expensive set of solutions on the whole McKinsey graph. Much, much more expensive than nuclear power, which I think of as a fairly expensive thing. And much more expensive than a bunch of natural solutions like restoring soils, restoring degraded forests, reducing slash and burn agriculture. Look how wide that bar is. That means it reduces a lot of emissions. That means if we can work with communities in the parts of the world where slash and burn agriculture is practiced, mostly the tropics, to help them do things a different way, we can make a huge difference for the climate. Okay. Good. It's solvable. See, I'm starting to pull the rabbit out. You can see its left ear. Excuse me. No, I've got this right. Sorry. I thought I had TEDed it wrong. Chad and Fatma Oliver, Chad Oliver is a professor at Yale, Fatma Oliver is his wife, published a really, really interesting blog in 2019 that looks at total fossil energy use around the world. Right now, around the world, we use about 580 quads of energy a year. A quad of energy is a quadrillion British thermal units. Aren't you so glad we didn't adopt the metric system now? So 580 quads is the total use. 500 quads is the part that's coming from fossil fuels of any sort. So what are we going to do? They said, well, we could avoid burning some fossil fuels. We could stop making electricity from fossil fuels. And they estimated that to do this by 2060, we would only have to slightly more than double the current rate of installation of renewable energy. That's not that hard. That's not hard at all. Think about what we did in America in World War II, when we went from having, I think it was 11 aircraft carriers at the beginning of the war, to producing 11 a month by the end of the war. We can do that. Okay, good. I'm getting ahead of myself. Insulating houses better, gets rid of another 70 quads. Replacing steel and concrete with wood in construction, which we'll talk about more in just a minute, gets rid of another 80 quads. That's pretty good. That gets rid of 260 quads. That leaves you with 240 still to go. What do you do about those? Well, they propose using wood waste to burn it in place of fossil fuels for another 30 quads. They propose that you're going to switch entirely to electric autos and trucks. And for those of you who are worried about that, I owned a Chevy Volt until it got really old, and because I put a lot of miles on it, because I was commuting from the Berkshires to Boston pretty much twice a week. And the Volt was the sportiest, most fun car that I ever drove, and it needed virtually no maintenance cost during the entire time I owned it. It was incredible. You should all want electric cars, as Andrew Yang said. He was right about that. So we're going to switch to electric autos and trucks, and we're going to fuel them renewably. That's another 90 quads. We're going to use concentrated solar power, these arrays of solar panels that steam up, that create massive amounts of steam. For another 50 quads, they pull 70 more quads of renewable energy out of their rabbit hat, and that gets them to 240 quads, leaving 0 quads remaining. There's a plan. There it is. It's published. We can go do this. And it doesn't require anything that we don't know how to do. Okay. Let's turn to forests, because you guys are here to talk about forests. So, forests today store 638 gigatons of carbon in forest plants and soils and dead woody debris and all the aspects of the forest. That's a lot of carbon. That is more than the amount of carbon dioxide in the atmosphere today. So we want to keep that there. Is that all? If the fires in Australia, if that sort of destruction of forests starts happening on a global scale, our goose is cooked. We're going to double the amount of carbon dioxide in the atmosphere. We can't do that. We need our forests, and we need them to stay forests, and we need the carbon that is in them to largely stay there. Forests absorb about 1/3 of our emissions annually, and they could store more carbon, a lot more, if poorly managed and degraded forests were managed better. In addition, there's the problem of deforestation. And here in Massachusetts, you think about it in the Amazon where there's massive clearing for agriculture. That's a big problem. But we have our own share of deforestation problems right here in Massachusetts. The next version of Losing Ground, the publication that Massachusetts Audubon puts out every, I think, 5 years, is a little late coming out. I don't know quite what the holdup is. I thought it was already going to be out. But it documents that since the last edition, we've lost another 24,000 acres of forest land in Massachusetts. 18,000 of it to largely residential development, and 6,000 to renewable energy developments. That's kind of a Faustian bargain there. Mostly solar. And, that is a problem not only because the carbon that is in those forests is released when they are cut down to make way for solar farms or largely cut down to make way for residential development, but it also is eliminating the future potential to store more carbon. We need our forests to serve as a green carbon pump that constantly is sucking carbon out of the atmosphere, and we need to figure out how to capture that carbon for the long term and lock it away. So what are we going to do? So this is the solution that New England Forestry Foundation has put forward. We've put this out in a New York Times editorial. There's copies of that back there. and I encourage you all to take them. But it's really a pretty simple solution. End forest conversion. Quit cutting forests down to make them into something else, not forest. Solar panels, yeah, we need them. Let's put solar panels on solar canopies over every parking lot. Let's put solar canopies on every roof of every shopping center. Let's line the Mass Turnpike and every other major road in the state with solar panels before we cut down another acre of forest. Doesn't seem that hard. Second, we need more wood buildings in place of steel and concrete. And if we're going to have that wood, how are we going to do that? Because I already said we need the carbon that's in the forest to stay there, right? So we have to manage our forests better so that we can produce more wood, grow more wood per acre per year, so that we can both maintain harvest and continue to store carbon in the woods. That's the solution New England Forestry Foundation is putting forward. So just a little bit of detail. I've already talked about conversion of forests, building more with woods. This is the Lever Architecture headquarters in Portland, Oregon. It's a beautiful building. I've been in it. This is the new 6-story dormitory at Rhode Island School of Design, made from cross-laminated timber. This building started construction in June. Students moved into it in August of last year. So there's another advantage of mass timber construction. It's very, very fast. This is the 18-story Brock Commons dormitory at the University of British Columbia, which was the tallest wood building in the world, briefly, until the Mostjarnet Tower in Norway was completed last year, which is also 18 stories, but is like 60 meters taller for some reason. Not 60. 20 meters taller? It's taller. They seized it back. Now there's a 25-story wood building proposed for Minneapolis, so North America is going to jump back into the lead. This is the Treat Tower in Bergen, Norway, which is an apartment building right by the river in Bergen. It's beautiful. I've seen it. And this is the last benefit. So if you think about wood buildings, you have lower emissions to build the building because you're not making steel and concrete to build the building, or not as much anyway. You have carbon stored in the building. The wood is locked up in the building for decades or maybe centuries, and there's plans as to how you could reuse the wood and also alternatively turn it into biochar and bury it at the end of life of the building. So that's the second way these buildings help. The third way, to me, is the most important. They create the opportunity for a different pattern of development. Right now, you can't build a stick-built building more than about 5 stories tall or 5 stories over one of concrete for 6 stories total. That's what is allowed by code. You don't build a steel building, particularly a steel residential building, lower than about 12 stories. And the developers I've talked to have said they don't do that because it costs too much. And they don't make their money back unless they have at least 12 stories. So there's this gap. There's this density gap between 6 and 12 stories. You go to the Alewife T station in Cambridge at the end of the Red Line. It's all 6-story buildings around it. Why aren't those 10-story buildings or 12-story buildings so that more people could live close to transportation? You'd have fewer emissions from cars. You'd have less conversion of the forest. Well, wood buildings create that opportunity. These mass timber buildings excel in that 6 to 12-story range. That is the place where they are the most economical compared to other construction techniques, and they're now approved under the International Building Code, which is what applies to the U.S. and Canada. That's why it's international. The wood buildings are now by right use as of 2021 in 6, 9, 12, and 18-story versions with different requirements for each height. This is a key part of the solution. Obviously, if we're going to build wood buildings, we need more wood. Where are we going to get it? We have to manage our forests better. This is from a study done by the Harvard Forest that my boss, Bob Purcell, and Bob O'Connor from the state of Massachusetts, Executive Office of Environmental Affairs, Executive Office of Energy and Environmental Affairs, put together the specifications for. They looked at current trends in our forests in Massachusetts versus what was going to happen with kind of opportunistic growth, or self-sufficiency if the global economy collapsed, or what they called forests as infrastructure, which was managing forests to promote more growth of forests, but also harvesting the forest and using the wood to create more buildings and to replace steel and concrete as part of a climate solution. It was explicit. This came out in 2014, I believe. So the answer was you could double the harvest of wood, which is these bars below the line, compared to current use, and have pretty much as much carbon, 90-some-odd%, I think it was 96% as much carbon in the woods at the same time by doing better forestry, by applying the principles of silviculture that have been developed here in the United States and in Germany and in India, interestingly, over the last 150 years. So, NEF is codifying our approach to this based on our 75 years of experience managing the forests that we own. We own about 29,000 acres of forest scattered across New England, and we manage them. And we do those as demonstration forests. Peter Tucker manages one of our forests in Alford, Massachusetts. We tend to use local foresters wherever we work. The focus of our exemplary forestry is, first of all, to retain older trees and older stands. And by doing that, we maintain higher stocking. Our forests here in Massachusetts have about 27 cords per acre, or about 54 tons of carbon per acre. The average forest in Massachusetts has about 22 cords per acre, or about 44 tons of carbon dioxide equivalents per acre. So we've got significantly more carbon in our forests, even though we're harvesting and deriving product from our forests. We also need to focus on wildlife habitat. The forests aren't only ours. Climate change is not the only issue. We need more reserves as well as more better managed forests. And we need to protect other environmental values as well. So what happens if you put all that together? Right now, here in Massachusetts, and I'll show you this in a minute, we have a lot of carbon in our forests relative to the rest of New England. We could have more. There's no reason the rest of Massachusetts, that Massachusetts as a whole, couldn't have the same amount of carbon per acre as New England Forestry Foundation's forests have, or maybe even more in some habitats, particularly riparian river bottom habitats. But that isn't the case here in Massachusetts, and it's really not the case in the industrial lands of northern New England. There, most of the land is owned by people in large blocks who are managing that land for economic reasons. And over the last 30 years, there's been a transition from it being owned by major timber companies who tended to focus on having an insured supply of wood for a very long period of time, which resulted in them managing for rotations of 20, 30, 50, 70 years, so that there would always be wood available to them. And instead, the forests of northern New England are now owned primarily by investors, by timber investment management organizations and real estate investment trusts. And those tend to operate on 10-year time frames, and they are focused on providing the highest return to their investors within that 10-year time frame. Well, the highest return is always going to be to harvest whatever scrap of wood is out there. And so what you have in northern New England, as Dr. Mumaw showed us last time, is a massive carbon debt. You have a massive problem that has been created by the financial incentives that the forest is not what I would call well managed. It is managed for a pulpwood rotation. A lot of those lands are certified under FSC and SFI. They're considered, quote unquote, sustainable, but they are not doing what we need them to do in the face of the climate crisis. Just as we need to change our culverts, we need to change our forest management. If we change our forest management, we can make a huge difference. We modeled what it would happen if you applied our exemplary forestry principles to the forests of northern New England over the next 20 to 25 years. And if you could do that, you would store an additional 1.9 gigatons of carbon dioxide equivalent in the living forests of northern New England while still producing product. And that is equivalent to taking every vehicle off the road in New England for 20 years. That's not just every car, that's every truck, that's every tractor, that's every snowmobile. You could essentially offset the emissions from all of them, which would give us time to make them all electric. This is what we've got instead. I took this picture. This is an FSC certified tract in northern Maine. It's certified as sustainable. I can tell you, I looked at the forests on the stands on either side of this, and I talked to the guys and said, did this look different than those other stands? And they were like, no, it all looked the same. Those other stands were fine. There was nothing wrong with them that required a regeneration cut where you cut everything. What they've left there is a few scraggly birch trees, which are they're not gonna do anything, and they're probably not gonna regenerate themselves. And eventually you'll get a softwood regeneration on this landscape just because of where it is and because New England forests are super resilient. But this is not the kind of management we need. Okay. What do we need? Now we begin to get to frame, and I'm almost done. Oh my God, I'm going late. I'm so sorry. I'll try to be quick. I'm getting close to the end. This publication came out from Harvard Forest in 2002. A young woman, Mary Berlick, was the lead author, together with David Kittredge, a professor at UMass Amherst, and David Foster, the director of the Harvard Forest and a professor at Harvard. It noted that just setting aside our forests here in New England might not be the best environmental solution, because it could if we do that without changing our consumption of paper. How many of you touched a piece of paper today? Yeah, pretty much everybody. If we just stop harvesting locally without changing our consumption of paper and the pattern of use, all we're doing is driving the harvest out of the local area and into somewhere else. And as Mary Berlick and company pointed out, often the somewhere else has lower environmental standards and practices than we do. What they didn't point out is there are landscapes that have much higher carbon storage per acre than we have here in New England as well. And our forests are super resilient. We have these lovely glacial soils that are loaded with nutrients compared to a lot of forest systems. We have a very diverse forest. When I headed up the Nature Conservancy's work in Berkshire County, which, by the way, we have Angela Soroy, who heads up that work now, in the audience. Angela, wave so people can come talk to you afterwards. When I was heading up the Berkshire work, I once, just for fun, said, well, how many species of trees reach the canopy here in Berkshire County? And I spent a while compiling a list, looked at Pam Weatherby's Flora of Berkshire County and went through that and talked to some foresters, and I came up with 48 species that reach the canopy somewhere in Berkshire County. There's some of them that only do it in Sheffield, but southernmost Berkshire County. But anyway, 48 species that reach the canopy. Contrast that with, say, most of Oregon, where there's about 3 or 4 species that reach the canopy. We have a very resilient forest. So, if you're going to decide what to do with the forest, you have to have a frame that you're thinking about it in. Now, if you own that property, maybe you want to think about the one forested property by itself. And if you were going to try to do the most you could do for climate change with that one forested property, you might think that the best thing to do would be to completely stop harvest and pack as much carbon as you could into the boundaries of that property. Okay. If you look at the forests of a region, you might or might not come up with a different answer. Because right now, I would argue that the greatest imperative is regionally is to change the way the industrial forests of northern New England are harvested. That is the priority. That is what we need to do. New England Forestry Foundation is participating in the development of Maine's climate action plan through the Maine Climate Council, and I will tell you there is enormous resistance to the idea that we need to change practices on the industrial forest lands. And even we, as sort of seen as a respected forestry organization, as a pro-tree harvesting organization, are having a lot of trouble getting our point of view that there needs to be a change heard. If you look at the forests of the world, well, now you've got an answer. Because if we could change harvesting on a global scale, then we could store a lot more carbon. And again, if you could somehow manage all the forests of the world, which is a very difficult proposition, but if you could do it, and you could stop harvesting on all the forests of the world, that would pack as much carbon as possible into the living forests. But you're going to have to do something to replace the uses of that wood in the economy. You're going to have to, if you're not using wood for construction, what are you going to use instead? Steel and concrete are the obvious choices at the moment. There are some other ones coming along. People are talking about rammed earth houses. My girlfriend wants us to go take a straw bale house making course and consider building ourselves a straw bale house in coastal Oregon as for retirement. I don't know about that, but we might do that. So it's not like there are no other options, but there are no other options that are ready at scale. Today, tomorrow, we could switch from steel and concrete construction for most projects to wood-based construction. So, what do we want to do? If we have a Massachusetts frame, Massachusetts dominates the economy of New England. We have the most people, the most economic activity, the most financial power, the most political power. We have the highest in-forest carbon storage in the region. Here's the Harvard Forest version of the same map that Dr. Mumaw showed you a month ago. We have a history of catastrophic wind throw in our forests, so I actually worry about whether our trees are getting tall enough and old enough that we're at greater and greater risk of losing this carbon, but that's an issue. And we have a strong conservation ethic and a strong conservation community, and we have an electorate that believes in facts and therefore believes in climate change and has repeatedly shown a willingness to take action to address climate change. That's the Massachusetts frame that we have to work with. If we take that and we talk about what we want to do in New England, I would suggest that we want to maintain harvest while increasing productivity and use that increased productivity to focus on storing more carbon in the living forests of northern New England. This is going to require a lot of work in order to convince the landowners, who are mostly industrial forest companies or investors, that that's what they want to do. We should use the principles of good forestry to increase productivity. That will require some thinning. And so you're going to have some trees that are not well suited to lumber because they're scraggly or they're too small. What are you going to do with those? I would argue that probably we should use those for wood heat, although I do not in any way support burning wood for electricity, which is way too inefficient. But in general, that thinning and that management needs to be focused on longer rotations, longer lived products, and we need to be trying to grow bigger trees. 30 years ago? Was it really? No. 25 years ago, Bob Terriot, who was a fellow in southern Berkshire County who liked forest land and liked to buy forest land and had a lot of money, Bob convened a session to talk about his vision of big tree forestry. You were at that, were you not, Peter? Yeah. George Wislocki was there. I was there. I don't remember who else was there, but it was a good group. We need big tree forestry. We also need to incentivize wood construction. We really need these wood buildings to start popping up. more than they are right now. Right now, I can tell you all the ones in New England. There's about 4, 5, depending how 6, depending how you count some of the ones that are like big post and beam buildings. That I want to get to a place where I can't keep track, right? And I want to do that in a hurry. And so I already talked about this. We need more reserves, and we need to set aside our older forests and not harvest them. And that is super important because those forests will accumulate carbon in the soils, they will accumulate carbon in the dead and downed wood at a higher rate than other forests. And also, they're ecologically super important. NEF supports more forest reserves in New England. Our board has actually formally endorsed the Wildlands and Woodlands Vision, which calls for about tripling existing reserves. What we don't want to do is we don't want to fail to prioritize. We're facing a climate emergency, and whenever you face an emergency, one of the first things you have to do is decide what to do, and also, in order to decide what to do, you have to decide what not to do. Because if you try and do everything, if you're not making choices, you're not prioritizing. We have limited resources, we have limited political capital, we have limited allies that believe in forests and climate change. We need to work together towards the shared visions. This is maybe one of the places where Bill and I do disagree. I don't think that we should lock up all our forests. I think that that will drive more use of more fossil fuel intensive materials and will not, it also will have the effect of dividing the climate change constituency and the forestry constituency from the climate change constituency. And that weakens the solution that we really need. And we also need to address the loss of forests. More than forest harvesting, I think we need to move quickly to address the permanent loss of forest carbon that is associated with conversion of forests to development, including solar farms. And I'm 100% in favor of solar power. I put a solar panel, pretty big one, up on the house I used to own in Sheffield, well, in the yard of the house that I used to own in Sheffield, at a time when solar panel prices were a lot higher than they are now. And I don't regret that at all. And I'm sure my ex-wife doesn't regret it. We need solar power, but we don't need it replacing our forests. So, thank you very much. The other 2 handouts that are at the back of the room, I have our 1-page description of exemplary forestry for northern New England, which we focused on first because of the problems that I described with stocking in northern New England. We're now designing our exemplary forestry standards for southern New England. We had our first meeting on that a couple of weeks ago. And we also have a handout that's our Forest to Cities Climate Pledge. We're trying to build a movement. This is where I channel Bernie Sanders. We're trying to build a movement for a wood revolution. And we're trying to link our forests to our cities so that people appreciate what we have here in New England and are able to come together to save it and to save our climate. And so there's a Forest to Cities Climate Challenge pledge back there. I encourage all of you to take it home, and if you like it, read it. If you like it, you can check it out in more detail on our website. We have a whole Forest to Cities web page that's going to be live any day now. But if you are inspired to sign the pledge, please do, and send it back to us at New England Forestry Foundation. So thank you.